Right, so I'm going to be starting a new series where I'm going to do Project Euler in GoLang. I think this is a great exercise for beginners who want to get good at the syntaxes and get a good muscle memory for writing logic in the language. I'm going to go through some of the beginner-friendly problems in Project Euler and kind of show you how you can practice your writing logic in a new language that you're trying to learn. And uh, yeah, so I have an empty directory right here. I'm going to create a new directory. Let's call it uh, Project Euler Go or something. I'm going to cd into it. And well, the first thing to do in creating a Go project uh, is to initialize the module. So I'm going to just do Go mod in it, and I'll just like we need to give it a name. So I'm just gonna call it the same thing. Oops. I'm gonna open a new code instance in it. So now this has generated go.mod for us. I'm gonna create a main.go file here. That's step one. Next step would be to, I guess, create a makefile. And this is, you can, basically you can think of this as like writing your own API for the project itself, where you write your own scripts for the project, where each script would represent one way to interact with the project. So you can set up the tests in the project where the series of steps that you need to execute in order to like run the tests for the project, and also um, the different ways to build the project and run the project and so on. And you can pass you can pass your own arguments to the command line and so on through this makefile. Uh, so it's like creating your own API for the project itself. It's good practice. You get to play around with the project in different ways if you work this way. Anyway, the first thing that we need to do is initialize the project. So I'm just going to write package main and create a main function. And we're just going to do the beginner stuff. So I'm going to print line hello world should be good. Now, in order to run the project, we're going to need run here. And I guess we can do like a build method, which will do go build dot. If you build the project for us. It will generate the binary, and then we can do run, which will require the build. So I guess we can do something like this, and then we can do whatever the binary will be generated here. So we can store that in a constant. So binary file equals will be the name of the project. It should be this project unit. Yeah. I think we don't need to add those parentheses or the curly braces there. We just need to do build, which is just called this build method. And it's usually good to have the constants at the top, and then all the commands that you can run using the makefile. And then what you could do is essentially the name of the makefile is just that, and this would be the binary file name. Hmm. So yeah, I think we'll need to do something like that. Yeah, this works. So we need to have a tab here before we run the binary file. Anyway, so now when we run make run, it'll just run the project for us. If we do make build, it'll just build the project for us then, and we can manually uh, do something like this. Yeah, cool. And we can also add like a clean function here. So like a clean command, which will just do the clean and it will like delete our binary, whichever we have here. So, so we're gonna initialize Git in the project just to keep track of just to version control our project. And we can add a bunch of other commands as well, like if we want to like format something, then we can just do something like this, and it'll like format our project for us. We can let's see, the equivalent of cargo check would be something like go with cargo check in Rust. The equivalent of that in GoLang would be something like make wet. This will check the project for us if it's following best practices and everything. Now, the way we are gonna implement this CLI is by uh, we're gonna have arguments that we can pass to our project. So we can do something like uh, whatever the name of the script is, and we can do something like problem one. You can pass the input, which could be something like 10, and this will run problem one, the solution for problem one, and it will pass the input 10 here. So we'll be having two flags that we can pass essentially. Uh, so we need to incorporate that somehow into the makefile. Now we can do that by like, having variables. Like we can have a problem variable which by default will set to one, and input variable which also will set to one, and these can be overridden. And then we essentially pass them here. What's the right way? No, we'll need to have the dollar, and we can have the input as well in the same way. I think this should now whenever we run make run, it'll let's see what's wrong. Okay, yeah. So it's gonna run it with the default uh, values that we've set. If we pass something like problem equals one, input equals 1000, then it's going to pass that instead. And we're going to do the same thing with problem as well. Anyway, this is a good setup for having a make file to interact with the project. And you can like customize it the way you want your users to interact with your project and like developers to like work on the project alongside. The next thing we're going to do is build the CLI. So there's two different ways of like building the CLI in Golang. You can either use OS args, which it gives you the basic arguments that were passed into the command line. If we do something like this, format print line os.args, yeah. So this should print all of the arguments that were passed as an array. So this was one argument, this was another one, this was another. So we have essentially passed five arguments to the command line. So we can parse this manually, or we can there's a different like built-in method of doing this, which would be to use the flags in Golang, the the flag package. So we can define our own flags, which will be passed into the command line and which we expect the user to pass. If they're not passed, we can like raise exceptions and stuff. Uh, yeah. Mm, yeah, so it automatically generates the it automatically detects all of these different ways of passing flags to the command line, which is pretty cool. So I think we can use that instead of like we can do this initially, I guess, and then move to the arguments. So the way to parse these args would be to like run a for loop uh, over these args. So it would be something like if I we can have a bunch of flags that we want the user to input. It would be problem input, and this isn't how we define arrays in GoLang. So, so we can like loop through and see if our flag in I think this returns us two strings. It gives us the index as well, and I don't remember which one the index is, so I guess we'll find out. If I equals flags, then whatever the next thing will be would be the value of the flag. Anyway, we can do this, or we can make our life easier and just use the flag uh, package that's been provided for us. So expecting an int variable which we need to store somewhere. So this will be the problem. It will be like a where problem, which will be like an this, and we also have the input, and we can pass the address of the problem here, and we'll give the name of the flag. We need the default value of the problem flag, and then we need a description for the flag. So this is the problem number. Similarly, we do it with the input. There we go. So now, if I were to print both of these, then you should see the values for them, which we didn't. Let's see why that happened. Hmm. Let's see if we're passing them correctly, which we are. They're still showing one and one, which is weird. Oh yeah, we'll need to like run the flag.parse. This is a function we'll need to run in order to pass the arguments which are passed, in order to parse the arguments. Yep, there we go. So now using this, we can like create a nice command line interface for our project, which we will. Like we can, let's say, so we can have a problems directory where we will have a problem.go, and this could be package problems, and this will have a problem mapper of sort, which will be, and here we can have like a switch case, which will take the problem number, and it will have a case for each one, and this will return the, let's say, the solution for problem one, or we can return it and not have the bridge, and we can have it for each uh, each problem. and the problem number will come from the arguments for the function. It will just be an int, and solution would be, so we're returning a function which takes an integer, right? And it returns an integer. So the way to describe that in GoLang would be something like this, where we have an input coming in and we return an output or an error. So we probably need this. And yeah, that works. Cool. So we can like have a dummy solution one for now, which will take an input in and it will return an int, and let's just return 0 for now. And we need a default case which will just raise an error in case like nothing, there were no eh, there were no like problems matched. So we can just do like format error as no problem, no matching problem found or something. And let's see what the problem is. Hmm. Yeah, so this needs to be lowercase, I think. Oh, should not end with punctuation. Okay, got it. Cool. So now we can invoke that from here. We can do something like, let's see, we need to give a path to this module in our project, which will be doing something like this, slash problems. I think this should work. Does it not work? Imported and not used. Okay, there we go. Now we can pass the problem into here, and we also need to pass the, okay, so we get the solution back from this. So we can now invoke the solution with the input, and this will be our actual solution. So this will be final, let's say, and we can like print this out. Hmm. Final mismatch. Why is that? We are passing a problem number here, but and we are here. Returns two values. Okay. So it returns an error. So if error is nil, only then we do this stuff. Or we can like check if it is uh, if it is nil, then we do this. Or we can do something else. The better way of like doing this is doing something like this. If it's not nil, then we should probably panic and we should raise whatever error was raised. Else we carry on. Cool. Let's try running it. What's wrong? No matching problem found. Okay, we don't have a problem 23. We do have one. So yeah, there we go. So this the CLI that we've built so far is working. Now what we need to do is the actual problem solving. We need to go through all of the problems and basically solve them. Uh, I think we should probably create like a solutions and solution.go where we have all of the solutions, something like this, and we can like name it after the problem that we're trying to solve, that is solutions, and we can like import this which would be doing something like this. Get method going into the directory solution, and from solutions we would get multiples. Cool. Now, in the next video, we'll probably be going through at least two problems from this, trying to solve them. So, see you there.